Welcome, everyone. My name is Kris Fletcher. I am at BP Castrol, and
I am Brandon Marshall with Chemours.
we are here to talk to you guys today about fluid lifecycle management. We want to talk about how we manage the life cycle of the immersion cooling fluids so they're disposed of appropriately.
Yeah, so just kicking off real quick, we started our work stream earlier this year, and we really wanted to take a look at what do we do with the fluid when we've either reached the end of the usable life or when we reach the end of the life of the equipment, right? We want to make a change. And what we started to look at and where we've been focusing on is really what is the common vocabulary that we can use in this space, right? It's a little bit of an uncharted area. We've leveraged a lot of what other work streams are doing, but there was still some gaps that we had to fill. A lot of discussion around different types of recycling language we could plug in here. And then, of course, the second part of this was what are the different options and the paths that we can do, and how do we want to articulate that for industry so that it's usable and can help with the selection criteria. So currently, right now, we've outlined a lot of different areas that our work stream could potentially focus on, and we've collected a lot of ideas from the group as well as our own work stream. Right now, we're really just looking at the fluid recycling and destruction aspect of things. However, with that said, as we've gone through these conversations, there's been several other areas that have been addressed. Now, a few of these areas will be covered by other work streams that are at OCP. And as we move into 2025, we'll also be jumping into some different areas to help with the selection criteria as to when do you need to make that option? How do you know when a fluid needs to be brought to end of life?
All right, so let's get into some terminology. In order to be ensured that we're all aligned on the same page, we need to define common terminology. And for the single-phase solution, the least desirable option for the fluid at the end of life would be a destruction option. This would be the highest carbon cost for that fluid. What you would do is you would bring in a qualified waste hauler, and they would either incinerate the fluid or they would use it for some other fuel application. But essentially, we would combust those hydrocarbons, and they would no longer be available for reuse. Again, this is the least desirable option, but it's going to be out there because not everyone will have the means to recycle or recondition the fluid. So a more desirable option would be to find a way to reuse those single-phase immersion fluids. And there are essentially two broad options that are available to us. And as a community, we need to determine if these are truly viable options. The first would be a fluid reconditioning situation where this would be a closed-loop recycling option. The fluid provider or the fluid collector would then use not terribly carbon-intensive processes to filter and remove the contaminants that were introduced into the fluid through use, remove the water that was introduced into the fluid through use, potentially re-additize that fluid, and then put it back into service as an immersion cooling application. Again, this would be the least carbon-intensive option and probably the most desirable option from a carbon counting perspective. The second option for reuse of single-phase hydrocarbons would be a recycling option. This would be an open-loop recycling option, so you would essentially send your fluid to a re-refiner, and then less intensive refining processes would be used in order to return those molecules back into their virgin state, and then it would be probably reintroduced into some general lubricants application. And with today's technology, it would not likely be reintroduced as an immersion cooling application, in an immersion cooling application. In the future, as re-refiners come into play, it's likely that this could change, but with today's technology, this would likely go into some other lubricants application.
Yeah, so jumping over to two-phase, our work stream is moving in a little bit of a different way. So up front, looking at the chemistries that are out there today, as well as the chemistries that are being worked on that are in the public domain, we wanted to take an inventory very similar to what we did for the single phase of the potential destruction and recycling options. For the destruction side of things, there's two primary technologies that exist. Both of these are commercially available services that some of you actually may be using today for other fluorinated gases, such as your refrigerants portfolio. And we have right now incineration, which is the least desirable option. That's more of a traditional means. And then there's been several companies out there, and happy to share their names after the talk here if you're interested, who are also using plasma arc destruction, which is a different means that essentially reduces the potential emissions of destruction by 99.9%. So these are two potential options that are available to you, and a lot of this, very similar to what you see with the single-phase fluids, is going to be based off the fluid quality and what needs to be done in order to rework that fluid to a usable state. Now, on the recycling side of things, you have two primary means that you can use here, and it is going to vary based on the type of chemistry that you have, so I will caveat with that. At a very high level, traditional filtration means are a very effective way of removing contaminants such as plasticizers and moisture from the system if it's present. It's a very simple process that you can execute, again, commercially available today, used with other types of compounds that are out there in the world. And this could be an easy way, especially if you have a higher quality fluid, so a limited amount of contamination, to be able to reuse that fluid. The second option that you have, again, commercially available and used with other chemistries, is distillation. So if you have a heavily contaminated fluid, because of the properties of these fluids, you can use distillation columns to actually separate out different contaminants and be able to return that fluid back to a usable state. So the options that you have here, especially for recycling, are really going to vary based on the type of fluid that you're using and the quality of that fluid.
But before we can implement any of these recycling reconditioning options, we as an industry need to determine if the fluids that are created after recycling and after conditioning are of appropriate quality to put back into an immersion cooling situation. So as an industry, we need to take a look and define what properties we're looking for in those reconditioned or recycled fluids. And we can borrow a lot from the two-phase fluid refrigerants technology because they have established standards that they've implemented, and we can borrow a lot from them and create similar expectations of recycled and reconditioned fluids for the immersion cooling applications to ensure that the silicon manufacturers and the servers will be able to warrant a system that is immersed in a recycled or reconditioned fluid. Having said that, you're going to see this a lot today. We want you to get involved. We really want people to come into our call and provide your input onto what you think needs to happen in order to truly recondition and recycle these fluids. We have a call to action. Everyone's going to have a call to action. Please scan our QR code. There are links to our wiki and to sign up for our mailing list. Once we determine options for fluid reconditioning and recycling, we are going to delve into life cycle assessment, which is going to be a fabulously interesting conversation. And we want people with experience within LCAs to also join our work group and help just extend the quality of the discussions that we have. And with that, thank you very much.
Thank you.
Any questions? Yeah.
I was just wondering, are you considering using regenerated fluid, which has already been recycled in your assessment? Not only virgin fluids?
I'm sorry, what?
Are you considering also not only virgin fluids, but also regenerated, which was already recycled? So maybe for fluid.
Yes. So you're asking basically about our RBOs or the existing virgin fluid can be coming from a re-refined base oil stream. So I think that kind of discussion will look at the basic fundamental properties of the fluid to ensure it meets initial requirements. And that, I think, will be addressed in the requirements document that's being underwritten right now. And I believe that Peter will also be looking at defining appropriate base oils for use in these fluids. And we're looking at the physical properties of the base oil that would lead to a good quality immersion cooling, single-phase immersion cooling fluid. And if an RRBO or a re-refined base oil can meet those properties, then I think that would be considered an appropriate virgin fluid. And our time is up, so you can definitely come talk to us and get connected in our work group and bring that to the conversation. Also get connected with Peter and probably Amy.